Hi, I'm Theo Hall, and this is a presentation on renewable energy for my Environmental Sociology class at Elon University. For this presentation, I'm going to look at renewable energy sources from around the world, as well as close to home. The two that I'm going to focus on today are solar and wind energy. Now, I'm not here to tell you that the entire country needs to go green or else, but simply here to educate everyone about some neat changes in energy production around the world. This is the Martha S. and Carl H. Lindner III Hall on the campus of Elon University. It is proud to become the first building on campus to receive LEED Gold certification. I mention this because it is through the use of solar energy that the building can achieve this status. After speaking with the staff, I was lucky enough to be escorted up to the roof and was able to see how the building generates part of its yearly energy. These are photovoltaic panels that are located on both sides of the building's roof. The energy created by these panels is turned into electricity, which is then added in to the main grid for the building. Also, hidden from public view, the roof is home to a solar water heating system for the building. Water is run through the system and sent downstairs, where it is continually heated in this tank. The instruments on the tank can tell how much the water was heated by the sunlight, and then can enable other systems to heat the water if need be. Also found in the building, in the lobby, there is a touchscreen display that shows real-time energy usage for the building. It also includes the very energy that we just saw upstairs coming from the solar-powered systems. Another place that solar panels can be found on campus are attached to the motion detectors that show when people are crossing the street. Although solar energy is only used at Elon University on a small scale, it can also be found large scale for other countries and nations around the world. According to Lester Brown, in his book Plan B 4.0, until recently, the production of solar panels was concentrated in Japan, Germany, and the United States. But several new players have entered the field, with companies in China, Taiwan, the Philippines, South Korea, and the United Arab Emirates. Also according to Lester Brown, solar thermal electricity costs are falling fast. Today it costs roughly 12 to 18 cents per kilowatt hour. The U.S. Department of Energy goal is to invest in research that will lower the cost to 5.7 cents per kilowatt hour by 2020. The Middle East and North Africa are two places that can play a leading role in the future of solar power. In a report released by Greenpeace, the European Solar Thermal Power Industry Association, and the International Energy Agency's Solar PACES program, says that by 2025, the industry will attract nearly $20 billion a year in investment and employ up to 54,000 people. It will also have avoided the emission of 362 million tons of carbon into the atmosphere. The report also states that in 20 years, solar power could provide the same amount of electricity as 72 traditional coal-fired power stations. The next form of renewable energy that seems very interesting is wind energy. Coming from Lester Brown in his Plan B 4.0 book, he says that wind is the centerpiece of the Plan B energy economy. It is abundant, low cost, and widely distributed. It scales up easily and can be developed quickly. When oil wells go dry and coal seams run out, the Earth's wind resources cannot be depleted. This is a map for the wind speed across the continental United States. Looking at the purple over in the Great Plains, you can see that this area is where the United States is mostly focused on producing wind power plants. When looking at the wind farms on the land from Texas up to the north, there are other added benefits. For example, a wind turbine occupies only 1% of the land covered by the actual wind farm. This means that for farmers and ranchers to allow a wind farm onto their property, they will have to have no investment at all, and they can gain $3,000 to $10,000 a year to reinvest on the remaining 99% of their land. One negative aspect when looking at wind farms in the middle of the country, especially one that comes to my mind, is the NIMBY philosophy of people, or the not in my backyard. I know I wouldn't want to wake up every morning and walk outside to see a giant windmill spinning in my front lawn. An interesting fact about wind farms is that they don't necessarily have to be found on land. Many countries are actually moving their wind farms offshore, where the wind speed is actually faster than across land. To quote Lester Brown again, the United States is currently looking into their offshore wind possibilities. In addition to having enough land-based wind energy to satisfy national electricity needs several times over, the National Renewable Energy Lab has identified 1,000 gigawatts, which is 1,000 megawatts for every 1 gigawatt, of wind energy waiting to be tapped off the East Coast and 900 gigawatts off the West Coast. This offshore capacity alone is sufficient to power the U.S. economy. Aside from the United States, other countries are already tapping into their offshore wind possibilities. Europe is one of those countries. An assessment by a wind energy consulting group concluded that if governments aggressively develop vast offshore resources, wind could supply all of Europe's residential electricity by 2020. When looking out across all 70 countries now harnessing wind resources, many people have their eyes on Denmark. At 21% of their electricity supplied nationally to their country, they are the leaders in this category. Now, instead of having wind turbines out to sea or all across the land in wind farms, an innovative architect in the United Arab Emirates in Bahrain attached 3 wind turbines to the World Trade Center there, which provide 675 kilowatts of wind power to the building. This accounts for 11 to 15% of the tower's total power consumption for the year. The architect also designed this building to have 2 sides that are sail-shaped. This way, wind can be funneled through the 2 parts to creating a negative pressure zone, which accelerates the wind speed passing through the turbines. Before researching this topic for my environmental sociology class, I had no idea how widespread wind energy and solar energy was throughout the world. Whether it be from buildings in the United Arab Emirates to wind farms across Europe and the United States, or even to the solar panels on top of my class building, the widespread use of these renewable resources is astounding. Hopefully this project has introduced you to the 2 renewable resources of wind and solar energy. For Aaron Peake's Environmental Sociology class, I thank you for watching. I'm Theo Hall.